Hello, everyone. My name is SK. When I was asked to talk about this topic, NLP will revolutionize the whole stuff, I was very tempted to make some predictions. I wanted to say, okay, what's going to happen in the next 6 months? What's going to happen in the next 12 months, maybe 2 years or 3 years? And then I remembered a great professor by name Professor Philip Tetlock. Have you heard of his name? Philip Tetlock? You should check him on Wikipedia. He was a professor in UC Berkeley. Now he's moved to Wharton University for the last, I think, 7 years. He did a very interesting research. He tracked almost 280 experts who made lots and lots of prediction over a period of 20 years, and they made almost 28,000 predictions. And then he went back and checked whether the predictions came true or not. 28,000 predictions, 284 experts who normally come on the television or write in the papers or books predicting what's going to happen in the future, and over a period of 20 years, and he actually went back and checked. The summary of the research was, the more you are an expert in a certain topic, the less your predictions will come true. So if I go ahead and make predictions, that only shows that I'm not really an expert. That's what I'm trying to say. But I resisted the temptation to make predictions. I'm actually going to talk about two aspects of NLP, especially in the topic, NLP will revolutionize the industry. I'm going to talk about what are the various things that's happening today using NLP. And I'll also talk about what are the building blocks companies have been using, individuals have been using, or even the research organizations have been using to build these solutions which make it possible to solve these problems. Also, I think in the audience today, I don't know how many of you are pure techies who actually are hands-on people, and how many of you are managers who are trying to make things happen and may not necessarily be a real hands-on person. A quick hands, how many of you can claim yourself to be pure managers? Okay, no one? How many of you are techies? Okay, fantastic. I will try to take less time on the topic of what are things happening, and I'll try to explain how these things are happening, and I'll try to spend more time. Remember, it took, I was working on NLP solutions around 2.5 years ago. My second AI company was on NLP. We developed a solution which actually compares and ranks documents, and we applied that in the context of job descriptions versus resume. And when I say a resume, it's just not one PDF document, but it could be a combination of PDF document, your public profile information, including your Twitter or LinkedIn or whatever stuff, and also any special questions that the employer want to administer to these potential candidate. All of those put together would be a resume of the candidate, and we would actually compare and contrast. When we were doing that, this is almost 2 years ago, the amount of knowledge available in a fashion where you can understand easily was very, very less. There were lots of technical papers published. TensorFlow was, I think, 0.10 was the version available. Then I saw 0.11, 0.12, then 1.0. 1.0, I think, was released sometime in Jan or Feb of this year, 2017. Now I think it's 1.4. There were so many tools available, but the capability to understand these was not available. So it took actually a lot of time for me. I'm going to explain those building blocks in a very short time of maybe 45 minutes. Hopefully I'll do some justice. I want to just get some data for you guys. If you look into the number of stars, GitHub stars people have given for various frameworks available. If you look into TensorFlow, I think it has really, really taken off. And also some of the performances of the machine learning problems. In this case, visual question answering model. Tomorrow I'm actually speaking in this conference called H2O World, where I'm talking about image processing. One other question I'll try to answer in the conference tomorrow is, how do you develop a model that actually can visually understand a question and also answer the question based on the images given? For example, if you have a picture of a street light with traffic lights with red, green, and yellow, and if the current image is green, And if you ask the model what color is the traffic light, it actually figures out. And it tries to identify the red colors in the image belong to the vehicle, so I should not pay attention to that, but I should only pay attention to where the traffic sign shows red, green, and yellow, and which one is actually brighter. So visual question answering is it is reaching there. I think it's coming to the human performance. If you look into the translations, translation model, I'll talk about how to do a translation. I'll talk about the paper that was published by Google on GNMT, Google Neural Machine Translation Model. I'll try to explain how it works in the short time available. But if you look into the blue score is 0.4. 1.0 blue score means the machine is producing a translation near human performance. And 0.4 looks very, very low, but imagine a machine picking up what you're saying in a source language and converting that into a target language. Some statistics. McKinsey has reported, I think 2016, companies have spent almost anywhere between 25 to $39 billion. And I think 2017, 18, 19 is going to be a huge amount of investments happening. I was just talking to someone a few minutes ago. My theory is, if you're an engineer, if you're a finance person, if you're an HR person, if you're a non-engineer, if you don't know AI in the next 3 years, there's a very high chance that you lose your job. I know there are so many other technologies that have come in the last 10, 15 years. People make predictions. I'm making a prediction. People made predictions, may not have happened or may have happened, but at least the initial enthusiasm, the amount of success companies are seeing using AI and ML solutions, and the availability of solutions both in terms of software or hardware and availability of techniques seems to create that self-sustaining ecosystem that may take this movement forward. So I have a lesser doubt for our AI. McKinsey also published a report that majority of the money being spent by the companies is in statistical ML, but also if you look into the next biggest is computer vision and NLP. Almost 30 years ago, there was a book written by Jeffrey Moore, Crossing the Chasm. If you have not read the book, I would recommend you should read the book. I'm not a paid advocate for the book, but this book is valid even today. The Crossing the Chasm is here where you have innovators who are developing newer solutions, newer ways of doing things, and you also have early adopters who are trying to adopt the technology or the solution to see how it's going to work. And typically between the innovators and the early adopters, there's always a chasm. There's always a stumbling block. Companies are a little scared because these are all maybe for-profit organizations or otherwise too. They are not sure whether they want to invest money in that technology. At the same time, on the left side of the screen, you might have seen this. If you have not seen Gartner hype cycles, you should go to my LinkedIn, and I've written a blog. I've collected all the hype cycles in emerging technology published by Gartner for the last 14 years. I think the earliest one I have picked is 2004. I have collected from 2004 to 2016. And what I always tell my friends and audience is, are they smart enough to make the predictions? If you really want to check that, look at the predictions from 2004 to 2012, and now it's 2017, so you can actually compare how the predictions came true or not. I think to a great extent the predictions have come true, but nevertheless, ignoring whether they came true or not, at the peak of the 2017 hype cycle for emerging technologies, you can see it's called deep learning and machine learning. And if you map the hype cycle with the Crossing the Chasm picture, we are there at that spot where companies are not very sure. Some companies are not very sure what to do and how to do. Some companies, I was actually speaking a couple of weeks ago in a conference called AI Europe in London, where I was talking about how to be an AI-ready company. Yes, you can see lots of media reports about, yes, there are a good number of solutions for AI, but how do I become an AI-ready company? If it's a small organization, a medium-sized organization, or a big company. But the chasm what companies are facing are some of those questions about how do I move from the innovators to the early adopters. And one of the things that will facilitate organizations to become an expert in NLP is if you have lots and lots of data. And this is again another McKinsey report. On the x-axis is how impactful is your AI or ML solutions on your business. On the y-axis is how much of volume of data you have in the organization. And if you look at and then identify the bunch of organizations and type of solutions, like at the top right, which is the highest potential, where the data is available and also high impactful, is personalizing advertisement. So if you're a high-tech company, if you're a product company trying to sell something, and if you have lots of data, that's one of the high impactful area you can start doing AI and ML solutions. Another McKinsey report talks about which companies are in the leading edge of adopting AI. This is, of course, based on 2016 reports, investments. Financial services, high-tech and communications is one, but also I could never imagine transportation and logistics is one of the earliest adopters of this technology. Okay, what are the various uses of NLP? So NLP will revolutionize industry. Means if you have a bunch of numbers in an organization, let's say you are tracking how your customers are behaving in a retail organization. Let's say you're an airlines company, you're tracking your customers who are buying tickets, taking the airlines, or canceling the tickets and all of that stuff. Having a prediction models, developing a prediction model, developing maybe optimization model, all that is possible using numbers because it's easy to do mathematical computations on numbers. But then the problem is for NLP, how do you develop these models which actually can use the text and make sense out of it? There are a bunch of ways of converting text into numbers, word to vectors, and other stuff. But ignoring the difficulty of how to convert a text into numbers, some of the use cases are, I could just put a few here, and I do have a lot of examples of how companies are doing it. I was talking to the founder of a healthcare company just a month ago. You know what they do? They are matching cancer patients with cancer trials going on in the world. And they're using AI solutions for that. I said, hang on, I may not be an expert guy, but you don't need an AI solution for that. You have a bunch of customers or patients with certain data points, and you have a bunch of trials going on, which you can convert into numbers, and you have to run a SQL statement on that. Yeah, but initially we're going to have a non-AI solution, but eventually we're going to be using AI solution. I said, okay, fine. Did you raise funds? They said, yes, we did raise funds. They raised funds for of $5 million to be spent in 18 months. So if you want to start a company, get easy funds, do something in AI, and do something in healthcare, you will absolutely get lots and lots of money. Whether you cater to the patients here in North America or Europe, doesn't matter. I think you'll get lots of money. Anyway, NLP in healthcare, you can imagine anything that you're doing today or you did in the last 1 year with respect to a healthcare situation. Tell me a problem statement, and I can tell you how to solve it using AI and ML. Whether you identify the right way of connecting to the right doctor, assessing the doctor's capability, or finding out how much money you end up going to spend, or if you're an insurance company, making a prediction on which customer is going to spend, which is going to incur more expense versus less expense. Or you can also make a prediction on which patient who went through a surgery will end up having infections because of surgery, and which patients will not get infections based on surgery. You can imagine, you can think of, let your mind run wild. Any problem statement you can think of in a healthcare situation, companies are working on. There's one company in Berkeley currently working on, started by a young PhD scholar, hired a bunch of maybe 8 to 10 graduates in computer science. You know what they're doing? They are developing a solution for Alzheimer's patients. Apparently, I did not know this, Alzheimer's patients lose a lot of muscle strength. So when they want to sit down on a chair or lie down on a bed, obviously they're doing it so slowly, but sometimes for an untrained eye, you may see that the patient is actually trying to sit on the chair, but actually the patient is falling down onto the chair or falling on the bed, not really lying down on the bed. And that only a trained nurse or a doctor can figure out. And you can't have a trained nurse or a doctor all the time dedicated to watching a patient. So what they're doing is developing video image processing solutions which actually can figure out when the patient is actually sitting down with his or her own volition and when they are not. So any solution, any problem statement you can think of. Let me see. Pick anyone we can talk about. You guys have any specific point you want to talk about?
Marketing.
Which is there a point here in this?
Specifically what? Using data science for marketing.
Marketing for new patients?
Not in healthcare.
Okay, I was actually looking at the healthcare, but I could talk about the situations too.
You want to look at diabetics, and you probably know, you've already been studying there. Diabetics is going to be the most important thing people want to study because that results in many other diseases.
Sure.
And it accentuates diseases and so on.
Yeah, absolutely.
There be blood thinning and all of that.
Sure, absolutely. But if you want to discuss any of the bullets I've mentioned there and how you can use ML or NLP to solve this, I'll be able to explain that. But yes.
So actually, I was wondering how are you actually applying NLP to this DNA-based precision medicine?
Yeah.
Repeat the question for the YouTube audience.
Okay. How are you using NLP for DNA-based analysis? Now, the analysis of just the DNA strings, which are a bunch of alphabets, that's not the NLP. Typically, when you try to analyze if the patient is going to have a more critical situation, or would this patient be able to solve the health situation he has now based on certain treatments given, in the DNA, what I've seen is people trying to look at historical data, which includes your structured and unstructured reports on, let's say, if you have a family situation or a family history of certain maybe mental or other physical problems, and would that be reflected in the DNA is one study companies are trying to do. Like, what would be the changes in the DNA strings of a patient based on certain preconditions, A, B, C, and those preconditions are being extracted from the structured and unstructured reports coming out from using NLP, the doctors. More NLP in healthcare. Let me pick one. Sure. The EHR, again, EHR is just more of a generic term, which actually, the question is, can you explain about EHR or EMR?
No, the application of NLP.
The application of NLP in EHR and EMR. EMR and EHR is more of a little more a generic term about what type of information you have about the patient. That includes your lab reports, for example. Many times the lab reports are a little more structured reports, but you also have the unstructured reports where the conversation you have with your doctor. I was actually talking to a company which is working on a healthcare solution using NLP, but they are also combining with audio and the text and the image processing. And one specific problem till now AI has not been successfully solved, and now companies are working on, is when you go talk to a doctor, the patient and doctor are having a conversation, how do you capture that vocal discussion that's happening? Well, you can do an audio recording of the whole conversation and do a transcription later on, where some hospitals actually do that. But the transcription is also done by a human being later on, which is again an expensive proposition. Like you also have a trained, medically trained person who's doing the transcription. Or if you want to use a non-human being, in this case our transcription services, the open source transcription services available have an accuracy of around 80-85%, not more than that. And you can't have, after every 100 words, 10-15 words are inaccurate in a medical industry, because then I think you have a life and death situation. This company is trying to see how they can improve the accuracy of the audio conversations of the doctor and patient. But anyway, coming back to your question about EHR and EMR, the unstructured reports like the conversation with the doctors and even sometimes the pathologist or the radiologist, when they give their report based on the images, what they see, that's also almost unstructured. Third type of unstructured reports in healthcare especially, this actually is very specific to healthcare, is every doctor or every group of doctors, even within a small hospital or a small clinic or even a bigger hospital, eventually they have their own language, how they talk and share information and communicate among themselves. For example, if a doctor says, get him EC4, even though EC4 is not a regular medical terminology, but the nurse who's going to respond to that EC4, he or she knows exactly what EC4 means. So eventually these small groups of doctors and nurses in some hospitals within the same hospital, maybe fourth floor doctor, a group of doctors and nurses will have a different language set, a little bit different from the others. And that will be another type of unstructured information. Now imagine if you're writing an NLP solution which will extract meaning out of these texts and convert that. I'll talk about briefly some of the tools available, how to extract information, but obviously it's not, 1 hour will not be a sufficient time. All of you guys are techie guys. Writing a SQL statement is not an easy thing. Now, there's a guy by name Richard Socher. He's joined Salesforce recently as a chief scientist. He's an extremely intelligent guy in NLP. He's a very renowned guy. I've read a bunch of his papers. I've seen a lot of his videos too. I met him for the first time around 6 months ago in a conference, and I was so excited. I took my life's first selfie with him. As you can see, I'm not a young guy anymore, so I don't believe in taking selfies. So I actually took a selfie. This gentleman, after joining Salesforce, one of the papers they published was, how do I translate a normal human spoken English sentence into a very efficient SQL statements? So eventually, that's another NLP solution. I took an odd area where publishing industry, how publishing industry can take the help of NLP to improve their own circulation or the reach or the revenues. As simple as just translating certain pieces of news to a different language, that's one of the things. But when you are trying to identify who are the right candidates for this write-up, instead of making a generic topic modeling, you can customize what topics can be shown to what specific person. So if you're actually profiling, in other words, if you're profiling your customer so well, then you can actually customize what you can show to these customers based on what you're publishing. I don't know, I'm sure you would have heard of chatbots. That's one of the NLP innovation. There is a chatbot written by a person, I think the person is in Europe, I guess, I'm not sure. She wrote a chatbot, actually she trained a chatbot almost to respond almost similar to the way I think her boyfriend used to do. So whenever she's not feeling well or whenever she's in a good mood, she starts chatting with the chatbot, and chatbot responds the way the person is to respond. The story is actually a sad story because obviously the person has lost, but the application from this is you can actually customize the chatbot in such a way that the chatbot knows what you like, what you don't like, and then respond accordingly. And eventually, I think you don't need.
The movie Her.
Oh, yeah, there you go. That's what I was thinking about. Yeah. I'm an advisor to a document management company, which is they maintain actually contracts for companies. After I started advising to this company, I figured out something amazing I never even knew. If you're a small company, let's say a 50 people company, 100 people company, you may have, let's say, 10, 15, 20, 30 contracts you write every year, and maybe you have an addendums coming up every year after that. And typically contracts expire maybe 2-3 years later, or 1 year, and then. If you're a big company like, let's say, Apple, HP, Google, Facebook, how many contracts they seem to be writing every year? Or how many contracts are valid on a yearly basis? Can you imagine the number? Go ahead, take a guess. Predict a number. 10,000. 50,000 typically. What I've heard is 50,000 contracts are being written. And many of these contracts could be as simple as maybe 2-3 pages, or it could be even 50 to 100 pages too. But let's say an average of 20-30 pages. Now, managing, even if you have 100 or a 200 size legal team managing the contracts, it's almost impossible to make sure that the contractual obligations are memorized, or you remember what those contractual obligations are, and kick those contractual clauses into force when something is not going according to what you expected it to. For example, if you have a supplier who would have to pay you a penalty if he or she does not reach, let's say, a metric, and unless you remember as a legal department or someone in the company that there is a clause which will actually make this supplier pay me a penalty, no one knows, and obviously the supplier may not even remind you that, oh, I got to pay you penalty in the case of that. So this company is trying to extract actionable clauses. First of all, identify what's an actionable clause. Next is what the action is. And third is what would be the trigger, and then create a bunch of rules engines to actually identify what the actions are and then take an action. You had a question?
Just related to that, there was a news article recently about, I think it was Walmart or some other grocery company. I think it was, I'm not sure. They said the suppliers were not supplying them in time. So they were going to charge them a certain.
Yes. Yeah.
I'm just wondering, did they use NLP in that case?
I don't know about NLP.
Can you repeat the question?
The question is, recently he read in the news that some company, maybe Walmart, triggered a penalty clause on some of the suppliers because they were not paying him in time. And his question was, you think they have used NLP in that context? I don't know the answer for that. No, I don't know what they have done. Walmart is one company, even though I hear lots of their presentations in meetups and conferences. It's another company which I don't hear too much about what they're doing for NLP. And I know that they have lots of data. Similar to IBM. I'm sorry if there are IBM fans here. I don't know what I hear about Watson and stuff, but what frameworks they use and what they're doing, what are the problems they're trying to solve, I don't have too much of information there. But again, anyway, coming back to the legal domain, there are companies and there are solutions available in NLP which will help you identify actionable clauses, dangerous clauses, sometimes even the contracts you get from a third party, even though you have your own contractual template, you have a supplier or an influential supplier or influential customer asking you to adopt their contract. In that case, how do you compare and contrast your contractual terms with the other contracts coming in? And you can solve that using NLP. Let me skip this. In financial services, I think one of the slides I showed you earlier, the huge amount of investments is in AI and ML, and of course NLP is also happening in financial services. I was co-facilitating a behavioral science conference in fintech. Have you heard of a gentleman by name Dan Ariely? Yeah, a fantastic guy.
Economist.
Sorry?
Behavioral economist.
Yeah, he's become an economist, and he's written a couple of books. Both the books are called Predictably Irrational. And he talks about lots and lots of examples of how human beings we think we are, oh my God, we are so intelligent, we are rational, we always do the right thing, but he will give you so many examples of how human beings do the exact opposite. So here is a story from that book. It actually goes towards behavioral science and financial world. There was a daycare center in Israel that was doing research. They found 10% or approximately that many parents come almost late every other day, 5 minutes late, 10 minutes late in the evening to pick up their kids. Now, because this daycare center is a for-profit organization, but even the workers in the daycare, they also have to go catch a train or a bus or leave for home. They feel it's not the right thing to do. You've got to come and pick your kid on time so that they can all go home too. They tried lots of emotionally convincing the parents, but 10% of the parents all the time come late. So I said, okay, no, we're not going to do this. We're going to actually put a penalty to these parents. Let's say 5 minutes, you pay $5. I don't know, whatever the currency is. On 10 minutes, maybe $10. What do you think would have happened?
Make it even later.
More people started coming late now. Why? Because the guilt factor is gone now. Now you're commercializing the guilt factor. Said, okay, fine, you want $10? I'll give you $10. But I'm going to come late because I'm paying for being late. So you can't even, I can't even be guilty looking, I can't even be smiling, I won't even have to apologize. Just say, I'll pay you $10 extra and then I'm going to come late. So they figured out it's not working. So they said, okay, fine, we're going to go back. They canceled the new policy. They said, we are going to do the previous. We're going to bring the original policy back. What do you think happened? The new behavior stayed. So the point is, this is one example of, there's so many other examples too, but humans don't necessarily behave in their own best interest. There is actually a sociological theory, maybe that might have been proved one more time in this country recently. There's a sociological theory that people will, in a democracy, people will eventually vote against their own interests. That is another example of behavioral science in finance, and of course that's the reason why I guess the Nobel Prize for Economics was given to Richard Thaler because of his contributions for behavioral science. So let's talk about how we can do all of these things. If you have done NLP earlier, or if you have a very faint understanding of NLP, or if you don't know anything about NLP, there are a bunch of libraries available. NLTK, Core NLP. Core NLP is a Stanford free open source tool available, which will run on your text to identify a bunch of things. Like, for example, what? If you want to find out, tell me all the names of people, organizations, cities in this sentence, and then I'm going to run a rules engine on it. There is something called NER, Named Entity Recognition. These libraries are pre-trained. If you want to do a custom training because the names and the names of objects and things you're going to be using is so different, in your context you can do a separate training, but all these pre-trained models can actually extract the names and the various other entities in the language. Co-reference, yeah, I think you should read this. President Xi Jinping of China on his first state visit to the United States showed off his familiarity. Or let me take a different example. The thieves stole the paintings, they were caught. Here they means the thieves. The thieves stole the paintings, they were restored. They is here about the paintings. The disambiguation, the co-reference disambiguation, also it figures out. So if you have a bunch of sentences where the subject of the sentence, whether referring to a certain person, if you have referred only at the starting of the paragraph, the model will figure out who you're talking about. Even when you say he or she, it will figure out what it is. So there is a area of study in NLP called question answering. Question answering is if you give a story to the model and then ask a question on the story, the model will be able to give you an accurate answer. And I'm not talking about a pattern matching where you have a sentence where you convert that exactly into a question, and then the model has to figure out what word is missing in the question. No, the model actually has to understand the story. So I'll give an example of what the story would be. Sally went to the kitchen. John went there too. It was a bright morning. Sally said a hi too. With our human intelligence, we figure out Sally is saying hi to John. But the model does not know Sally is saying hi to John because model does not know that John is in the kitchen. If I go back to the story, Sally went to the kitchen, John went there too. I didn't say John went to the kitchen. So NLP will actually solve these type of problems. So otherwise impossible looking problems are being solved in using NLP. I'll talk about some other impossible sounding, but whenever I hear the word impossible sounding, I want to ask you a question. If you play a wind instrument like a flute or a saxophone, and if you how long can you think you can hold a note? If you keep on playing without pausing to breathe, pausing to breathe, how long can you hold a note?
A couple minutes, because you can cycle into your mouth.
Indefinitely? Is that a couple of minutes? Maybe I'll come to that question. Maybe I'll ask in a different question first. And have you heard of yoga? Yoga is actually really good. If you don't do yoga, I think you should all do. But one of the important aspects of yoga is breathing exercises. So let's do some breathing exercise right now, okay? Either you can close your eyes or keep your eyes open. Take a deep breath inside and then do an exhalation. Make sure that the exhalation is longer than the inhalation, okay? Go ahead and do that, please. Take care. Now, how much time do you think you have taken for the inhalation, and also how much time you have taken for the exhalation? 10 seconds, 15 seconds each? Now, can you do simultaneously? Can you do inhalation and exhalation simultaneously? Sounds impossible. Going back to my first question, if you can you play a note for, let's say, if you think you can play a note for, let's say, half a minute or a minute, can you play, like this gentleman said, indefinitely? Is it even possible to hold a note indefinitely? Keep on playing. Greg already gave an answer. There is a concept, especially in Australian Aborigines, they have trained on a technique called circular breathing, where when you play a flute or a wind instrument, you collect a little bit of air in your mouth and you will start breathing in using your nostrils, but you're blowing air through your mouth. So you'll never have to actually take a pause to breathe while you're playing. So there is a gentleman by the name Kenny G. You should actually go Google search this person and then find out. There is a video. He actually can play for 45 minutes without even pausing for breathing. But of course, the video is not for 45 minutes. He actually shows 5 minutes video because you can't see 45 minutes video there just to prove the point. But so the impossible sounding, the point I'm trying to make is if something is impossible sounding, does not mean that you cannot solve. Some of these impossible sounding problems in text is being solved today using NLP. Let me give another story about there is a company, I think in 2015. I don't know the name of the company. It started in Boston. It was acquired within 8 months, it was acquired by GE. So they were around 50 people, I think, company. They were acquired for $350 million. Actually, for 8 months, 50 people, 350 million is a really decent number, right? You know what they were doing? When you go to a hospital and if you go for a certain treatment, let's say you got an X-ray or you got a blood test or you do something, when you claim an insurance reimbursement, you have to claim it against a specific code, an insurance code. Now, if you have, let's say if you're a patient and you actually go to the doctor, and if you go to the hospital over a period of 2 or 3 days and you do a bunch of tests, and if you have hundreds of such tests and hundreds of such patients coming in, it's humanly not possible to actually nurse to sit down and identify, oh, this task actually has this code, so I'm actually going to use this code. But if I'm applying to a different insurance company, they have a different coding mechanism, so I'm actually going to put a different code. And that's very, very humanly expensive. So this company wrote an NLP solution using the basic parts of speech tagging, NER tagging, and basic other extraction methods. They figured out, looking at the structured and the unstructured reports, they figure out which is an activity done by the hospital, and is that a standard activity, and does it have a unique insurance code for it. And all that they do is, for certain patient, for certain month, what were the activities done, what are the insurance codes, and now you have an insurance reports done automatically. So it's not only more accurate, extremely cheap, and fast too. Now, all of these insurance NLP problems which are being used for healthcare solution, if you say, oh my God, if I have to write that, do I need to build the models myself? No. People have already done that for you. There is this architecture called UIMA, which actually is a sort of a distributed technology to manage the data that's coming in the organization, both textual and otherwise. But this is not the best part. The next one is the best part. There is an Apache project called CTAKES, developed specifically for healthcare. If you run an unstructured text, 80% of the functions are already built in, which will do the mapping of various words, activities, whatever you can think of. So the patients, diseases, medicines, tests to be done, all of those things are already been done. You have to do, of course, some rules engines on top of it and maybe add some more vocab. But CTAKES is one of the many healthcare AI companies trying to develop the solutions would use CTAKES.
Can you talk about the different systems, if you could identify what's open source and what's commercial?
Sure. I normally like only open source software. It's cheaper.
Is this one open source?
Yes, this is free. This is Apache open source tool. Now let's actually talk about the real tech solutions. You know, for any type of ML solution, whether it's a textual or otherwise, the most fundamental block is called recurrent neural networks, RNNs. What's an RNN? It's a neural network which actually takes an input in a sequence, one after the other, understands what that input is, and then makes sense out of it. So that's the naive, non-tech explanation of what an RNN is. RNNs were used for text processing, where if you have a sentence called "the cat sat on the mat," you introduce the word "the cat sat on the mat" in a sequence. RNN takes that word by word and understands. And if you have trained the model to do a translation of this sentence to a target language, the RNN starts outputting what is the translated sentence looks like in this target language. RNNs are not that favored in NLP as of today, because RNNs don't have the memory capability. It can't remember or take in more than 10 words or 8 to 10 words when it starts forgetting what was the first word, second word it has seen. So then came something called a variation of RNN called LSTM, long short-term memory. You should read all, if you guys have not seen this, I think you read that blog. It's one of the most famous blogs. I don't know about you guys, I had to read it 3 times. And for that matter, I think every technical paper, even today, I have to write 2-3 times. I'm not that smart. But you should, if you don't understand, please don't be scared, because that's the situation with a lot of people, and you can read multiple times. The LSTM is a variation of RNN. It takes more words without forgetting. According to Chris Manning, a professor in Stanford University, an expert in NLP, he says you should take 100 as a number. It will remember almost 100 words. After that, it starts forgetting what was the first word and the second word, and if you start putting more and more. And if you have these 100 words, let the neural network do something with that, and then input new set of things. No machine learning, no NLP solution or a technique can be explained without mathematics. How many of you guys still remember your algebra or mathematics? I'm sure in your school you have done mathematics, but yeah? Yes? A long time ago when I was teaching in a university, because I liked teaching in a university, I was very nervous. How do I make sure I make a good impression on the students? So I went up to a professor who's actually a real renowned person. I said, give me a few tips, because I'm going to be speaking, I'm going to be a teacher, lecturer, or a professor for the students, and I want to really make a good impression. This is very simple. Keep on talking till they pay attention. The moment they stop paying attention, don't talk anymore. Leave for the day. I said, okay. But how do I know they're paying attention? I said 2 or 3 body language. One is they have the pen and a paper out, or their laptops out, furiously typing, making notes. The facial expressions are changing. If you walk up and down, their eyes walk with you. So that means they're really engaged. Second body language is they are once in a while typing. They look at you. When you walk up and down, they look at you, but not much excitement. Third body language is they've leaned back on the chair, they've crossed their hands, laptop is down, and when you ask a question, no response, that's when they say, the professor told me, you should stop. So the question is, have you done mathematics in your school, or do you remember your mathematics even now? Yes. Okay, there you go. Yeah, my story worked. It's almost impossible to talk about any NLP or ML solution without mathematics in this case. But if you look into this bunch of mathematics here, the only thing you have to remember, if you really want to understand what LSTM is and how LSTM works, there's something called a hidden state, HT, at the bottom one. HT is the hidden state of LSTM, which is nothing else but the summary of the information you have given the model till now. If you have given 10 words, 20 words, 30 words, 40 words, whatever it is, whatever you have given, the model has understood those words and kept in the memory, and using the HT, using the hidden state, you can actually make the model work. How do you make it work? Let's take an example. So you have a bunch of RNNs or LSTMs. You give an input called A, B, C, and end of statement token. The model will take A, B, and C, understands what A, B, C stand for, and the moment it encounters end of statement token, it says, okay, fine, the input job is done, now the output job needs to be done. So it starts outputting W, X, Y, Z, and end of statement. And if it's a translation or a summary, whatever it is, I think it start doing the word, start doing the activity. So you give an input as a sequence, and you get an output as a sequence. It's called sequence to sequence. So if you encounter, let's say if you are so excited one day, you just don't like falling asleep tonight, I want to read a paper, technical paper, that's the best way of falling asleep. So if you get a technical paper in NLP, you'll fall asleep easy. But if you're still not falling asleep, sequence to sequence is one of the most fundamental things. Even today, I'll show you some examples of how Google has done in the machine translation. They're just a sequence models. They use a different term. They've used a bunch of techniques on top, but it's a sequence to sequence, where it takes a sequence of ABC, EOS as an input, and it gives W, X, Y, Z, EOS as an output. That's what sequence model is. Now then, let's say if you have a model where you want to do a language translation from a source language to a target language. The cat sat on the mat, English, and then you want to translate it to, let's say, German or French. You give the input sequence, the cat sat on the mat, end of statement, token, and then it starts outputting the output in the language you want it to. But then people felt, hang on, human beings, when you read, let's say, a sentence or 3 sentences or 10 sentences, when you start writing a translation for it, many times, halfway through, you go back and say, hang on, what was the sentence, or what was the word I read in the second sentence? What was the third word in the second sentence I read? So you actually go back and look at the input one more time. Machine learning experts actually introduced that concept, and it's called attention. When you are translating or summarizing or doing any NLP activity, at every act, every time step of your output, the model would train itself to go check certain places of the input so that the accuracy of its output would improve. That's an attention technique. So any machine learning solution or any NLP solution you read today, whether it's a question answering model or a machine translation model or summarization model, some type of attention technique is implemented. So you have a sequence to sequence technique and attention technique. So I know today, by the end of my talk, I may not be able to explain to you completely how a machine translation works or a summarization works, but I am confident that when you go back and read a blog or a technical paper on machine translation, actually I have a slide where I talk about some papers. When you go home and read that paper, I don't think you will be confused when you see the words sequence to sequence and attention, because the most 2 or 3 fundamental building blocks for any of these solutions are these 3. You have an LSTM, you have a sequence to sequence model, you have an attention. Next building block is something called language model. The technical definition of a language model is the model will tell you or predict what is the next right word in the sentence. If you have given an incomplete sentence, the model will predict what word will come next, and then after it's done with that word, it goes to the next and the next and the next, till it encounters end of sentence, which is typically a period or a comma or whatever other things, and it keeps on outputting. But the non-technical description of a language model is, imagine this. Language model is like a human being who has read lots and lots of text, and in that process, he or she has figured out the right structure of a sentence. So what is grammatically correct sentence in that language? So typically, language models are trained on Wikipedia. Wikipedia has almost 3 million articles, and the types of articles are so diverse. It could be sports and cooking and politics and whatever. The language model trained on Wikipedia information is smart enough to figure out if you give a grammatically erroneous sentence, it will figure out that it's error. And if you give an incomplete sentence, excuse me, it starts predicting what the next the word is. That's a language model. Language models are used as an addition to, let's say, a machine translation or a question answering model when the model is not able to figure out the correct sentence structure, but it actually figured out the most important part of, let's say, the translation or the question answering. It has figured out the answer in the question answering model, or figured out what should be the important collection of words I'm going to be using after translating, but I'm not able to form a sentence using those words in that language. Then comes language model. There's a gentleman by name Andrej Karpathy. He's the head of machine learning in Tesla. He was a Stanford PhD until a few years ago, and then he was also teaching in Stanford. He's an expert in image processing. Actually, he's more famous for image processing. But he wrote these models on a title. He wrote a blog called Unreasonable Effectiveness of RNNs. He actually trained this is one of the fantastic applications of NLP. Do you know Shakespeare, William Shakespeare? Is he alive? He's dead, right? So obviously you can't expect any new novel from Shakespeare coming anymore, right? He's done. Andrej Karpathy has trained a RNN model based on the previous stories or novels or books written by Shakespeare, he has trained a model to understand the writing style of Shakespeare, and actually after that it starts writing a story in the similar style as Shakespeare. This is the output, this is the actual output of the model trained on Shakespeare's novels, not written by Shakespeare. There may not be a plot in this, in the sentences, because I think the model has not still figured out. Maybe that's what I think you guys need to invent going forward, maybe the next 6 months. You should think about how to write a model which actually can even create a plot. But in the absence of a plot, the way Shakespeare used to write, when you give Pandarus, maybe that name doesn't even exist, but I think the model created a name called Pandarus, and it's a human being. So it puts that in character in caps, and then put a colon. Then, alas, it figured out in those days, or in Shakespeare's style, alas is a term which is used to express exasperation or whatever. And look at when to add a period, when to add a new sentence, when to add a comma. Whose noble souls I'll have the heart of the wars. Again, there is no meaning in the sentences yet. But the model has figured out exactly how Shakespeare writes. This model actually wrote a novel, not a novel, I think he just wrote a couple of pages of a story that looks very similar to how Shakespeare would have written. Yes, sir?
How much of this plagiarization aspect of it versus real writing?
Yeah. The characters here and the sentences are not seen in any of those things. So the model is actually imagining, creating certain characters, and it knows whenever it has a character, it will be written in capital letters, and the dialogue or the sentences will be written below in the regular language. It figured out all of that thing. But I don't know if it's plagiarism or not, but what I think he's trying to do, I think he's trying to show the capability of an NLP solution like RNN of creating something by training based on the existing information. It actually can create something new.
Yeah, because I'm an expert on Shakespeare, all his novels in detail.
Okay.
So, a lot of barfing and
Sure. Yeah. Possible. I've not read Shakespeare. You had a question, sir?
What was that movie called, Sunspring?
Sunspring?
Where the AI wrote a movie script?
I don't know, but I'll not be surprised. Yeah, there must be. There might have been.
Yeah, there's on YouTube the main character that was the main character from Silicon Valley. It's pretty funny to watch because it's being acted out.
Sure. Yeah.
Can you repeat that question or comment?
The question is, have you heard of the a TV episode called Sunscreen, or a movie called Sunscreen, which is apparently written, the story is written by an AI model, apparently. I've never heard of it. Yes, sir, you had a question?
Just from a more practical perspective.
The NLP use cases till now, what I have seen is, if you have such text with you, in whatever format it is, it can take the intent or the meaning from the text and help a human being figure out what the intent is, what the action is. Can the model create something new by looking at, let's say, an RFP and then creating a solution? I've not heard of solutions there. I've not heard of use cases there, people are doing it. But right now, based on whatever people are publishing papers and what my knowledge also says is, if we have some information available, let's say you have a contractual document, or if you have a patient information, or if you have a big massive 10K or 10Q document by a company, public company ABC, and if you want to have a small summary of it, which you want to give it to your shareholders. Any type of activity where you have a bunch of text available, and if you want to extract meaning from that and create a little more sensible solutions or actions, that is possible today. But based on certain things, can you create something brand new? I've not heard of it. The RFP solutions, no. The response to RFP, I don't think there's a model yet for that. Yes. The question, I think, let me repeat his question, was are there any NLP models available which will respond to an RFP and RFQ? My answer is no, I haven't heard of it. Yes, sir.
You talked about translation of Latin languages so far, like English and German and so forth. How about things like character building now?
Chinese and Arabic and stuff?
Yeah.
Oh, yeah. The question is, there are models available for language translations from English to, let's say, French and German, and how about in translation to languages where the language is a pictorial language, like a Chinese and Japanese and such languages?
That exists.
That exists, yeah. The language translation is a huge area of study. Today, there are lots of solutions and models available to translate from English to certain similarly structured languages like German and French, because typically if in English you have the subject and the verb and the object, and you also in German and French, the structure is almost similar, not the same, but almost similar. Whereas if you go to, let's say, a Chinese language or an Arabic language or even Japanese language, the structure is so different. So the sequence of words and the meanings of each word is so different. For example, let me complicate the question. Your question was, how do I translate into languages which don't have the structure? There are certain languages where there is no pause between the words. It's one sentence. There's no you cannot impose a pause on it. If you are an expert in that language, you know what it is, but not like an English language where between every two words there is a pause. There's a gap there. There is research going on to develop solutions in that context too, but they're not enough available because the biggest problem in NLP, whether it's question answering and translation and summarization, is the availability of data sets. No one is actually spending enough time and money to create the data set. Actually, that's my second suggestion. If you want to start a company, forget about machine learning solutions. Develop data sets. People actually will pay lots of money. Go to a country where the labor is cheaper, develop a data set, have a Q&A done on that data set and sell it to companies. People will be very, very happy to pay lots of money for your data sets. So another idea, if you want to start a company, you should do that. Okay. Google Neural Machine Translation Model was published, I think, in 2017, sometime in May, June. That's the paper, if you guys want to read it. This is the architecture. There are a lot of building blocks used in this. So I'm actually going to look at my screen here. You guys can look at it. On the left side, you have the LSTM layer, but you have a bidirectional LSTM layer. What does it mean? The cat sat on the mat, let's say, and if you feed the sentence as it appears to the model, and eventually you want the model to translate that, sometimes the model has to know not just the words in the past, but also the words coming in the future, number one. Number two, model will remember the most recent word, the highest, and maybe a little lesser, and they go on. So 10th word or the 50th word or the 100th word, it remembers the least, but it remembers the most, the word it has just now heard or seen. So by having a bidirectional LSTM, so when you have a left to right LSTM, unidirectional left to right, that is, you actually go on the sentence from the left to right side, and the reverse right to left side directional LSTM, it starts reading the last word first and the next word second and the next word third. So it actually starts reading in the reverse way. And at every time step, when you combine the hidden state of the model would actually know just the last one or two words and also the one or two words in the future, because the reverse directional LSTM actually has looked at the words which are coming later. So bidirectional LSTMs would actually enhance the accuracy and the capability of the model. That's the only reason why you actually use bidirectional LSTM. And the accuracy of the model here in Google's case, they actually used 8-layer encoder and decoder. Now, that's a new term again. Let me go back to explain that. You see in this picture I talked about a sequence to sequence where you input the entire sequence and then it gives an output sequence. Initially people said, okay, we'll use the same LSTM model or LSTM or RNN for the input and also the output. That means you're actually sharing the weights. Later on the new concept is, no, I'm going to use one LSTM for the input and another LSTM for the output, where these two LSTMs don't share the weights, and apparently this technique, it was more efficient, more accurate and more efficient. So that approach is called encoder and decoder. So LSTM, which is taking the inputs in, is called, because it's encoding the stuff coming in, it's called encoder, and the decoder is the LSTM which actually is outputting the information, which is sort of a decoding, whether it's a translation or summarization or question answering. So in this model, they have used encoder and decoder. So on the left side, you actually have the bidirectional encoder for the bidirectional encoding is on the layer 1. Then you actually have 8 layers for both encoder and decoder. They have residual connections. Residual connections, sometimes you actually let the model pick the input from 2 layers above or 2 layers previous, so that you actually get the information more efficiently, and this also helped the accuracy of the model. They've used attention. Yes, sir.
If this were statistics, you would be increasing the precision of the model by double counting, but you would be going further and further away from the probable accuracy. If this were pure statistics, now since it's all hidden away in magic arctan formulas, Lord knows what's going on. But isn't that the real danger? Is that you'll come to a really strong belief in a really bad solution?
Yeah, the question is, these techniques, what I'm explaining, sounds like more of increasing the precision, but not necessarily the accuracy of it. You know, that's actually a good question. Typically, when I say it's a good question, means I don't have a fantastic answer. But anyway, I'll try to give an answer anyway. In statistical machine learning, if you use any model for prediction, etc., the quality of the predictions, the quality of the model is measured using a bunch of metrics. Accuracy, precision, recall, F1, these are some of the metrics people use. And it's just because the model is accurate does not mean it's the best model. I'll give an example for that, but in statistical machine learning, these metrics, precision, accuracy, recall, F1, they all have a distinct meaning and they actually have a distinct application, and in every context you actually pay more attention to certain metrics and not the other metrics. In text processing, it's actually very, very difficult to use any of these metrics. For example, when you do a translation, and you have a model which actually translates from English to, let's say, German, how would you know the model is doing an excellent job? Because you have to compare the model translated sentence with a human translated sentence and then say, okay, if the model comes close enough to the human, then the model is really a good one. But the problem is, the translation also is so human specific. The way you translate into French or German and the way I translate, the way another person translates, could be slightly different. So in that case, how do you compare and contrast the quality of it? So blue scores, and there's another way of measuring called rogue scores. Those are the two scores, two metrics people use for measuring the accuracy, call whatever it is, precision. But coming back to, I think that's not your question. I think your question is, by using these so many techniques, are we getting into more of...
Is what I'm saying.
Sorry?
You're double counting.
You're double counting. What I have realized when I asked similar questions, like, for example, I asked this Richard Swatcher a question, when would you use one-hot vectors and when would you use word-to-vec when you're trying to translate words into vectors, and when would they respond to, give a better quality response? He said, I don't know. I have seen one-hot vectors giving a fantastic response. The models trained on one-hot vectors are giving better response. And in certain other contexts, models trained on word-to-vector is giving better response. The reason why he could not answer that too was the AI and NLP or ML research is going so fast. No one is doing a controlled experiment to find, okay, if this are the 3 impacting factors, let me control these 2 and then vary these 3 to see what the impact is, and I'll control these 2 and then vary this factor, and then that type of controlled experiments are not happening because people don't have time for that. If the metric if accepted metric is a blue score, or accepted metric is an accuracy or a recall, if that's what is the metric you want to compare, people are developing models which actually improves the metric. That's one. Number 2, if you have doubts about which metric is the best metric, because there's so much of a debate the metric itself may not be the right one, many researchers nowadays what they use the same data set. That is another way of proving that if using that data set, even though the metric is a wrong definition of metric, but for the same data set, you're getting such a number, but my model is giving a better number for that same data set, irrespective of whether the metric definition is wrong metric, but still my model is better because for the same wrong definition, mine is proving better. I'm giving a long answer. Is it a double count? I don't know. But the GNMT model, when they were introduced, I think just recently, 6 months ago, it was running, I think, on production, I think, for almost a year, but they published a paper around 8 months ago. This seems to come very close to human performance. It seems to be one of the best models available compared to all other models. So I don't know whether they're double counting or not, but right now I think that seems to be performing well, and they're using an NLP solution and seems to work fine.
So if it works, doesn't matter. It's magic.
Actually, yes, if it works, doesn't matter. You're right. There is a famous, I'm actually, again, tomorrow when I'm speaking on image processing, there's a great gentleman by the name Jeff Hinton. He has been working on a newer concept of image processing tools or techniques called Capsule nets. Actually, the first time he mentioned about those was in 2011, but he did not have enough data to prove or enough evidence to prove. So just October of 2017, he published 2 papers, and one is already published out, one is in the peer review. Both are available in public domain. There he talks for the first time with evidence that capsule networks are doing better than regular convolutional neural networks, CNNs. But he said CNNs work so well, which is actually so bad. But that's a pity that they work so well. I know they are very bad, but they work so well, everyone wants to go with that. And hence he took 6 years to find evidence that CNNs are bad. So if you guys are into image processing, I think it's a little more complicated theoretical thing, but you should read this paper on capsule networks, which says that CNNs are worse and capsule network actually does a better job of image processing. Yes, sir.
About the translation from one language to another.
Yeah, that's a very good comment. Actually, I tell people to do almost a similar experiment. Pick 2 iPhones. You have Google Translator app on that. Open one app for English to, let's say, German, and the other app from German to English, and then tell the first model, let's say in English, whatever you want to say, and let the model respond in German to the other translator, and let the translators talk to each other. After some time, the English sentence that's coming out is completely gibberish. So you're right. When you do from source language to target language, and when you do a reverse, it doesn't have to be exactly the same. And that's why the whole problem of going back to his question too, about the accuracy and precision, recall, etc. What is the right metric? People, I think we just don't have, because the human dependency of whether it's summarization or translation.
And also depends on the subject. Whether it's a scientific article versus a literary, piece, the translation quality will be.
Yeah, absolutely. Yeah. I was talking to a gentleman, I think, before the start of the presentation. I was told in English has 500,000 words vocab, typical language what you guys and you and me speak. But if you go to the medical industry, apparently there is 3 million words being used, pure English words, not even derived from any foreign language, but just the pure English words used in the medical world is 3 million. So it's more complicated, I think, in that case too. Before I did my second company, I was working on NLP and I was trying to run some experiments. One of the experiments I ran was doing a question answering. There are a bunch of data sets available where you can compare. There's a CNN data set, you have a Daily Mail data set which actually can take it and then run a question answering model, and then it'll tell you how accurately it's responding. But instead of using that data set, I've used an Indian story. If anyone in the audience are Indians, There's a story called Mahabharata. It's actually a fantastic epic of Indian people. So it's a massive story running into thousands of lines or millions of lines actually of text.
8 chapters.
It's a huge story. So I trained the model on that, and then fortunately, actually, we got a decent accuracy. That's when I figured out, okay, maybe I'm not that stupid the way I look. I think I'm slightly better than the way I look. So that's when I started actually working on my second company. This is a model, actually, a paper published on how to develop a question answering. There are 3 different techniques where you have a story, where you feed the model with the story. Then you feed the model with the context and the question. Model will figure out what is the answer for this question from this story, but within this context. It will be so amazing if you actually look at some of these reports. One I mentioned to you earlier, Sally went to the kitchen, John went there too. Model actually comprehends the story, understands the story, and gives an answer. For example, each one of these is slightly different from the other. For example, on the attentive reader, you actually have a bidirectional STM, you actually have a left to right and right to left, but there is an attention on the encoder and there is an attention on the decoder. The encoder is on the 4 blocks on the left, and the decoder is on the 3 blocks on the right side. So you actually have LSTM, but you actually have a bidirectional LSTM, you have an attention model, and then you figure out the answer. And in this case, the impatient reader, instead of using the attention model only for as a static activity, you actually go back and check the attention at every time step. That's the variation on impatient reader. And the 2-layer deep LSTM reader is a extremely simpler model where it just takes two unidirectional LSTMs, read the same text. One is in context, one is a question, combines the hidden state of both the LSTMs and figures out the answer. Again, I'm jumping back to the language translation. Many papers until recently have done experiments on translating from one language to the other language, a source language to a target language. This paper, I think, was published maybe 2016, I'm not sure, where they tried to train a model not from one to one, but one to many. So here, the model, you take a bidirectional STM at the bottom as an encoder, you input x1, x2, x3, or XLS as the input, but then you're translated into multiple languages and using the same hidden state, and the model actually did a very good job of that. But I've not seen this model being used in many situations, maybe because I think they didn't have enough time to focus or did not have enough support, but what it is. This is another paper written by Richard Socher, as I mentioned to you, from Salesforce. The model is, even though it looks complicated, it's extremely simple. I'll explain it to you. The green boxes on the left side is the LSTM encoder, which is taking the input as a sequence. The United States became the largest, tech company in the world, tech country in the world. After reading every word, the model is updating its hidden state. And all the hidden states are being combined as an attention, and the combined attentive hidden state is C, the green C on the top. Now, during training, the summarized version starts with US tech, and for that, decoder LSTM has its own hidden state that's being updated as the blue C. H is a hidden state at a specific time step T of the model, and all of these 3 hidden states are being combined to make a prediction what the next word is. This is during training. During inference, of course, the model actually just looks at the input text and outputs. So this complex model, at least it looks complex here, but it is using 3 different types of hidden states. The input hidden state or the encoder hidden state, and the encoder hidden state is every hidden state is being combined into one hidden state, and the decoder hidden state at every time step, and the decoder hidden state at a specific time step when you're doing inferring or when you're doing training.
When you say hidden state, is it a vector of?
It's a vector. The non-technical explanation of hidden state is when you give a series of inputs to an STM model, the model is actually updating its numbers internally. It's actually a big matrix number, millions of numbers in it, just a big matrix. It's updating its numbers to remember and understand what you have given the model till now. That's what the non-tech explanation. The tech explanation is actually a number, a bunch of numbers in a matrix. Let's say it could be hundreds of thousands. 0, 1, 1, 2, 3, 5, 6, 7, 0, 1, 2, 5, 8, 9, 8, whatever thing, it's a bunch of numbers. And every time you give an input, the model assimilates that because the word coming in is a vector, and it assimilates that and updates its weights. Especially if it takes a few words at a time, it actually does a back propagation and updates the weights. The updated weights would be the reflection of the inputs you have given till now. In other words, the wisdom you have given the model till now is what is updated in your weights. So that's the tech way of explaining it. Anyway, so that's a simple paper. So all of these 4 or 5 papers I'm referring to here, starting from this question answering model, multitask learning for multiple languages, and of course neural attention model, and of course the GNMT here. If you get a chance, I think you should read these papers, and if you don't understand the very first instance, I think try it multiple times. You will really enjoy what they have done. And the best slide of my presentation is this. That's it from my side today, gentlemen, ladies. Greg. Yes, sir. Thank you. Thank you. You had a question?